Today we're going to start talking about a few more numbers and some graphs and a little bit more vocabulary, of course, because we haven't had enough of that yet. And of course, I'm going to start off talking about candy because I love candy. The biggest weakness of mine is candy. So here's a list that you have on your sheet there. While I'm writing this up there, I want you to think, if you had to choose one of these, which one would you choose? Yeah. You only get to choose one, sorry. You have to choose one and only one of these categories. And I'm going to do the first column here only, the frequency. You already have all this. So everybody ready for their first choice? Your only choice? It's a hard decision for some of us. Now, if I had lots of time, I would maybe start over here and go one person at a time and say, okay, what's your choice? What's your choice? And you can each tell me. And then I would count how many of you chose Reese's, how many of you chose Skittles, so forth. But that's a little bit time consuming. Let me ask you a question. Are you going to give me categorical or quantitative variable when I ask you this question? Categorical, right? You're all picking a category. I'm actually going to count how many are in each category, but the answer is a type of candy or none if you don't eat candy. So let's go through and do this. Everybody gets to vote only once and has to vote once. How many of you choose M&M's plain? Keep your hands up while I count, please. 1, 2, 3, 4, 5, 6, 7. How about peanut? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Skittles? Popular today. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Reese's Pieces? 1, 2, 3, 4, 5, 6, 7. Did you guys see it? Have you seen the new one where they put the Reese's Pieces inside the peanut butter cup? I just saw that commercial this weekend. Oh, it looks so good. And how many of you don't want any candy? All of you eat candy? We do. Good for you. Okay, not really. It's not good for you. Sometimes you need a little. And all of those are my choice depending on my mood. You know, sometimes you want chocolate, but sometimes you need Skittles. It just kind of depends, right? Anyhow, okay, so what we just did is I essentially asked each of you a question. What's your candy? Which one's yours? And so forth. And then I counted them, and I put those numbers in the frequency column. Frequency just means how often did that answer show up. So if I had asked you individually, 7 times somebody would have said M&M's plain. And 11 times somebody would have said M&M's peanut. Let me close this door. Frequencies are sometimes helpful, sometimes it's not as useful. Example, let's say I ask all Americans some question about candy, and I can tell you that 7,983 of them chose Skittles. Well, that's a nice big number. But it's nice to know out of how many. To know how compared to all the other categories. So what we do is we change these into percents, and that's what we mean when we talk about relative frequencies. That's the next column on here. Relative frequencies. Turn them into percents. So now we have a review question. 7 of you said you like plain M&Ms. How do I turn that into a percent?
Out of 100?
Yeah.
And then divide, you said peanut runs, you said?
I think I said plain. I might have said peanut. I meant the first one.
You said 7 divided by.
So she says, so I heard a couple things. So she's over here telling me first I have to add up how many there are here. Somebody else said out of 100. They're both accurate in a sense, but the first thing is we need to know 7 out of how many. So we have to know the total even though I didn't ask for it. You cannot find relative frequencies without finding the total. So I'm assuming that you guys can add or your calculator is nearby. See if we can find this total. 1839? Is that right?
Yeah.
Yeah.
We've got some people missing, a lot more on my roster. Did everybody vote? Oh no, it makes me nervous. Okay, we'll say it's 39. Okay, so the total's 39. So 7 out of the 39 said they liked played M&Ms. So to turn that into a percent, kind of going back to our review from the first day. What would we do? She's already told me once. Somebody else know what to do? Turn that into a percent?
Divide 7 by 39.
Divide 7 by 39, right? I'm just gonna put it off to the side right now here. 7 divided by 39, that becomes a decimal of some sort. Hopefully somebody has their calculator out, can you tell me what that decimal is?
Rounding is 18%.
Before you round, please.
17.94.
And some more after that.
Yeah.
Yeah. It keeps going, but she gave me the first 4 digits. So when we divide, that's what we get. If we want to turn it to a percent, we reviewed this, remember, last week, seems like forever ago. We want to turn that into a percent, we move the decimal over 2 places, or you multiply by 100. So if we did that, it would be 17.94%. And then, I heard you say 18%, both of you said that. We have to make sure we're clear on what the directions are in terms of rounding. If this problem is on, say, my stat lab for homework tonight, it will say, give me the relative frequencies, and it might say round to 1 decimal place. That always means round to that many after the decimal. So if they did say round to 1, my answer would be 17.9%. If it said round to the nearest whole number, then I'd go with your 18. So make sure, there's always a little blue box, you know, underneath the directions on the MyStatLab. It tells you where it wants you to round. So I'm going to leave it as 17.9%. Questions on how I got that? Now, what about the out of 100 comment that I heard? It plays in here somewhere. If I had 100 people, 17.9, almost 18 of 100 people would have said they liked playing. If we were talking about counting people, we would have to round and say, if we had 100 of you, 18 would have said that. That's what a percent is telling us. What would it be out of 100? Everyone all right with that? You know how to get the rest of them? I'm gonna let you get the rest of them. Always have your calculator out when you're in my class, by the way. I'll ask you to do this quite a bit. Let's see if you can get them. Fill in the rest of that table, the relative frequency column. And round them all to the 10th place, 1 decimal place. If you're not sure what to do, ask your neighbor or raise your hand. Or both.
Did you say round to the 10?
To the 10th place, yeah, just like we did here. If the directions, if I hadn't told you where to round, usually you can choose to round wherever you'd like. I know when you're online with online homework, it tells you where it wants you to round, so it knows how to grade you accurately.
Yeah, it's super specific.
It is. You learn real quick to read those directions to make sure that you're, because what happens is you're usually right, but then you don't read those directions and you get it wrong for the wrong reason. Some of us are quicker at dividing than others. So let's fill the rest of these in. What about for peanut M&Ms, what do we get? 28.2?
Yeah.
And Skittles? 35 point what?
9.
35.9%? Oh, same thing, I should have been able to handle that. I can get the last one too. Questions on where those numbers came from? Let me ask you a question. What should those numbers add up to? They should add up to 100%, because everybody got counted in there somewhere, so they should add up to 100%. Even though you're not asked to do that, I always recommend adding all of these to make sure they add up to 100%, because if they don't, you know you made a mistake somewhere. A quick way to find if you made a mistake. So if we add those all up, what did you guys add? I think I see what it adds up to. Tell me if I'm wrong. I think it only adds up to 99.9%. Where'd the other 0.1% go? Yeah, you know, because we rounded everything, it's quite possible that we're not gonna get exactly 100. I wouldn't have been surprised if it was 100.1, 0.1 over, 0.1 under, or it could have been exactly 100%, and that's just because we were rounding. I'm not too concerned it wasn't exactly 100. If it's off by anything more than that one little decimal place, I'd be worried. Something happened wrong, I did a wrong calculation, we'll fix it. When you're doing relative frequencies, sometimes they don't make them percents, they leave them in decimal form. Like they would have listed all these numbers, 0.1794, 0.282, and then the next step they ask you to turn them into percents. Again, it's reading the directions on the MyStatLab. I'll take them either way if I ask for it, but the MyStatLab is very picky about which way it wants them. So frequency is just how often it shows up. Relative frequency is in percents, because now you can actually compare the categories. And you can say more than a third of the people chose Skittles. A third is 33.3%. Now that I have the percent, I can really see that it's more than a third. Just telling you 14 people chose Skittles is kind of tough to see what that means, but it's more than a third. The same number chose here and here, you could have seen that already. But percents kind of help us compare things a little bit better. Okay, so the last column is cumulative frequency. It's not real helpful in categories, in categorical data. It's more helpful in quantitative, which we'll see, but we're still going to talk about it so you know where it comes from. Cumulative, make sure you're writing down these notes on how we're finding these. Cumulative. Starts off with the number in the first category, and that number just gets brought over here. And then it's everything in this category and this one combined. So I had 7 people chose plain M&Ms, 11 people chose peanut M&Ms, so combined, I had 18 people choose both these categories. So we're just adding those together. So this number here is 18. I got that by adding the 7 plus the 11. And then the next one down will be, okay, how many people chose these 3 categories? So I would need to know these 7 people plus these 11 plus these 14. I would take that 14 added to my 18 I already had. So do you have looks on your faces that make me think there might be a question? Question on where these are coming from? So 32 people chose one of the first 3 categories. That's all that means. And then the next one would be adding this 7, that would be 39. And then adding the 0, still 39. Notice that this number and this number are the same. They better be. 39 was our total number of people. 39 is the number of people that chose this category or one of the ones above it, which is all of our categories. So there better be everybody in there. So that's where we use cumulative. I didn't bring any candy, sorry. Have you seen all the new flavors of M&M's, too? There's so many new ones. The caramel, oh, love those. Love those. All right, so make sure that under relative and cumulative, you explain to yourself how to find those, what they mean. Changing the fractions, percents, adding up the totals, whatever you need to write for what we just did. Questions before we look down at example A? Okay, So look at that table for example A. And while I'm recreating it roughly here, I want you to think about explaining what the heck all these numbers mean, how you would interpret this, because I'm going to ask a couple of you to help me out here. I'm just recreating what you have in front of you, so I can point at it and talk about it as we go through this. Some of the hardest part of statistics is just understanding what all the numbers mean. Putting labels on them. Who wants to take a shot at explaining to me what this table represents? Yeah.
Is it the price of homes and how many are sold per price within those price ranges?
Price of homes, how many were sold? She's right, but we need to be even more specific because I don't think anyone bought a house for $80.
Okay. That was in thousands.
Aha, so we need to make sure we're real clear. See where it says in thousands? Price in thousands? So now the 80 means $80,000. And over here we have frequencies. So somebody tell me what this 3 represents.
Homes, the homes that are sold. In between
Correct.
that price range.
Okay, I want someone else to try, 'cause I think you got it. I'm glad you got it. Someone else try to tell me, using, like, interpret this row for me in words. Uh-oh, does silence mean nobody knows, or we're all shy? Yes.
So it just means that 3 homes were sold between the price range of $204,000 to $234,900.
Beautiful. Let me repeat what she said. 3 homes were sold between the price range of $204,000 and $234.9 thousand. What is $234.9 thousand? Hold that thought. $234.9 thousand.
234,900.
Beautiful. 234,900. Right, the comma is where the point is, really. So we're saying that between here and here, there were 3 homes between 204,000 and 234,900. A lot of times, if you don't know what the table even tells you, how are you going to answer any questions about it, right? You want to be able to answer the questions. So 3 homes were sold in that price range. How much was each one of those houses? Great question. Great question. There were 3 homes in this range. What were the prices of those homes?
You don't know.
There.
We don't know. All we know is they were somewhere in there. They could have all 3 been 204,000. Could have been one was 204, one was 205, one was 206,000. We don't know. Everyone agree that we just know that we have a range? Similar if I asked you, raise your hand if you make between $10 and $12 an hour. You would raise your hand, but I wouldn't know how much you get. Do you get $11.50? Do you get 10? So we only have a summary of the results here. How many total houses was somebody looking at when they made this table? How many houses? Did I hear 28? Where did you get that?
The frequency.
We added the frequencies. So frequencies are essentially how many prices I looked at. I looked at 28 prices and just counted how many were in this range, how many are in that range, and so forth. So we add those all up. There are 28 houses in there. All right, so let's get into the vocabulary. This is called a frequency distribution. The frequency distribution just tells you your frequencies for a certain number of categories. That's what we have over here. What's different here is each house gave me a quantitative variable. It gave me a number, the price. So the first house might have been 89,000, another house might have been 236,000. So each house had a price associated with it. So I have quantitative variables. And so what I do is I divide all those numbers into what's called classes. That's why it says class limits at the top of your page there. Classes. These are kind of like classes, but the classes are defined by numbers over here. Okay? The first thing we want to talk about are the class limits. Those are the easiest ones. The class limits are the smaller and the bigger numbers. This is the 80 is the lower class limit. This is the upper class limit, meaning we're counting all houses between 80,000 and 110.9 thousand. Each class has limits. So a question on the exam might be, what are the class limits for the last class? And the class limits would be 235.0 and 265.9. Each class has a lower and upper limit. That's the easiest one we got. Now it gets a little confusing. Okay, on limits. I'm going to skip over class boundaries because that's the hardest one. And class midpoints is a little bit easier than that, but I'm going to go down to the very bottom of the page to where it says class width. Do not be the person who gets this wrong on your quiz or your exams. I'm going to tell you the most common error is to think, oh, class width, you're thinking of how wide it is. So people subtract these two numbers to see how far it is from here to here. Kind of seems obvious that's what you'd want to do. That's not what you want to do. Because you ever understand that the width makes you think you should figure out how wide that one is? Look at what it says. The difference between two consecutive lower class limits. Yes, sir.
Would that be like 141.9 minus 110.9?
So those are upper class limits, but yes, it works there as well. Let me get another color and talk about it. It turns out the upper works just as well. So he wants to look at this number and this number. Those are consecutive limits. Those are consecutive upper class limits. It works there as well. Consecutive means one right after the other. If we subtract those, 141.9 minus 110.9, what do you get? 31? 31. My red pen is not showing up. I have to switch colors. We agree that's 31? If we took the actual definition that said use lower class limits, maybe I would pick the 173.0 and the one right after it. Consecutive means one right after the other. It doesn't matter which one you pick. If I took those two and subtracted, I still get 31. I hope. I better. Not someone made the table wrong. So to find the class width, you're talking about how far is it from one class to the next one. If you subtract these two numbers, you'll get 31. If you subtract these two, you'll get 31, and so forth. All the way down this side, and all the way down that side. So class width is not how wide one class is by itself, it's how far from one to the next one. Okay on class width? Guys are quiet today, it makes me nervous. Okay, moving up the page. The next one up says the class midpoints. The value in the middle of each class. The value in the middle of each class. Exactly halfway, the middle, halfway between 80 and 110.9 would be the middle. How do I find that?
Add them together and divide by 2.
Add them together and divide by 2, she says.
Yeah.
What is that essentially doing?
Finding the average.
Finding the average, which we're going to stop using that word a little bit later semester, maybe next time. But right now we'll call it the average, that's what you've called it before. Add them up and divide by 2 to see what's halfway between. So just for the first class, bless you,
Thank you.
I'm going to take the 80 plus, where did it go? 110.9. Add those up, then divide by 2.
95.45.
We agree? Someone agree with her? Yes, Bill? Yeah, some nods?
Yes.
Not that I don't trust her, but we all make mistakes with our calculator, we gotta agree. I did this once, I don't remember what class it was, where someone answered like that, and we went on and it was like an hour and a half later, someone goes, you know, wasn't that supposed to be a 7? Speak up if you don't agree. Either you're wrong or she's wrong and we gotta figure out, but luckily we're all agreeing. If you didn't get that number, double check your work. Make sure you add before you divide. So what is this number?
What's in the middle?
It's the middle, it's the mean, it's the average, it's the class midpoint for the first class. This is the midpoint for the first class. So the directions on your online homework or in your written lab will say, list all the class midpoints. List all the class midpoints. How many should I have? I should have 6 because I have 6 classes. So I'm going to calculate the next one with you and then we'll talk about shortcuts. Shortcuts are always nice. We love shortcuts. Let's calculate the next class midpoint. What am I going to do?
The same thing.
Same thing, but start with the 111.0 and 141.9. Add those up, divide by 2.
You should change the subtraction into addition.
Oh, thank you. Add those up. I said add, didn't I? My brain said add, my hand said subtract. One of them had to be right. Thank you. What do I get?
126.45.
126.45? So that's the midpoint for the second class? Now technically we could do that 4 more times. I have faith that you could all do that 4 more times. But I don't want to do it 4 more times. You know this class width that we found earlier that I didn't label? Here it is again, we found it a couple times. Let's talk about how we found both of these over here. We found the 31 the first time by looking at 2 consecutive upper limits. And we found this 31 over here by looking at 2 consecutive lower class limits. Well, here's 2 consecutive midpoints.
You just like add 31.
Yeah,
Exactly. If you subtract them, they're 31 apart from each other. So what would be the easiest way to get all my other class midpoints? Jenna just said it. Jenna, right? Just keep adding 31, right? Because each class is 31 away from the next one. Instead of doing all these averaging, this is my second class. The shortcut would be to just add 31, that'll give you the next one, add 31, that'll give you the next one. Anything that lines up, the lower classes will line up, the upper classes will line up, the midpoints will line up. So the easy way here is just keep adding 31. Add 31, I now have 157.45. These guys here are my midpoints so far. You can keep doing the averaging if you want. If you're a math nerd like me, you think it's fun. Sometimes we like shortcuts to save time though. Is everyone okay with what I did here? I added in my head, don't tell me if I'm wrong, please. Please tell me if I'm wrong. So the next one, I'm going to add 31 again. That's 188. See what I'm doing there? Sarah, can you not read my writing?
No, I can't.
Okay. Is there anyone that wants to know why I'm adding 31? Yes, you want to know? Okay. All right. You okay with how I got these two though? Okay, so we could keep doing that. And so if I averaged these two, if I averaged those two, you could check me, you would get this number. And if you average the next one, you'd get this number, and so forth. But because we already found that the class width was 31, we add 31 to get to here, and here, and here, and here, and so forth on this side. Think about the middle. If the middle is right here, there's no number written there, I would add 31 to get to the next one every time. So instead of calculating all those averages, we're just adding 31 to find what the next one will be. It just saves us some time. You don't have to do it that way, but it's a lot quicker. Especially when you're doing them online and there's maybe, 8 classes or something, that's a lot of averages to do. So once you find the class width, it makes finding the rest of those really easy. Well, we need a couple more. I found how many so far? 4 of them? So what's the next one? Did you guys find it already? There's 2 more, right? 1, 2, 3, 4. Let you guys find it. 219? We agree with her?
Yep.
And the next one?
250.45.
250.45? So these numbers in these boxes here are my class midpoints. If you're doing this one on my stat lab, it's going to ask you to list them all separated by commas. So you would type 95.45, comma, 126.45, comma, and so forth. Anybody who's afraid they couldn't do this on their own? So does that mean you don't have any questions? You know how to find the midpoints? We know how to use the class width to find them quicker? Okay, so that's class midpoints. Now's the hardest part. The class boundaries. So I'm back up to the third thing in my little list down there. So we talked about upper and lower class limits. Those are lower and upper limits, lower and upper. We talked about midpoints, which we were just calculating, the numbers right in the middle. Class width was the difference between 2 classes, but now the boundaries. You can read it, but it doesn't make a lot of sense. Values used to separate classes, halfway between an upper limit and the next lower limit. I'm going to draw a number line. I'm going to draw a number line to explain what they're talking about, because I think when you put all these numbers in order, it makes more sense. So let's say, and that's a straight line, 80.0. 80.0. I'm starting with 80.0. My next class, that class ends at 110.9. I'm kind of exaggerating and making a big space before the next one starts. Try to put it sideways so we don't run out of room. 111.0, and then the next one ends at 141.9, and the next one starts at 142, and it keeps going. We'll use some color here. So we all agree that my first class is between here and here, and my next class goes between 111 and here. And I deliberately left big spaces. I know technically they're not that big, but that way you can see them. Those are all my classes on a number line. The class boundaries are the numbers in between the classes. Like this number right here is a class boundary. Yes, sir?
So 0.1 basically.
0.1? What do you mean? No, it's the actual number on the number line. So this number is 110.9. This number is 111.
So wait, so would it be like 110.95 or something?
It will end up being 110.95. We'll talk about how she figured that out. But we're talking about the number that's halfway between here and here. I'm just going to draw visually first, then we'll talk about how to calculate it. In between, there's more. I didn't draw all my classes. Everyone okay? Like on a number line, the number that comes between 110.9 and 111.0. Visually, we're okay with that? How do we find halfway between 2 numbers? Add them up and divide by 2, just like we were doing before, right? So this point right here is going to be 110.9 plus 111.0, bless you, allergic to stats today. Adding them up and dividing by 2. And hopefully you get the same thing that Jenna did in her head when she was guessing. Or maybe she was calculating, I don't know. 110.95. That is one of my boundaries. Questions on that number? Let me show you how it relates to this. We're talking about the number that comes after this outside of this class, so it's not in this class, right? It's a little bit bigger than this class, but before this one. It's not in this class, and it's not in that one. It's halfway between those two. That's a boundary. How about this next one right here? 141.9 plus 142.0 divided by 2. You should end up with 141.95. Questions on where those are coming from? Again, notice 141.95 is at the after this guy, outside of this class, but before this class. Here's a question for you. Without using your calculator, what do you think the difference is between these two class boundaries? Oh, you guys are brilliant today. That class width is your best friend. If these are 31 apart from each other, how can I find the rest of my boundaries? Keep adding 31. So if we keep adding 31, 172. I added 31 to this one to find the next one. Make sure you're putting that in your notes somewhere. And if we do the next one, 31, what is that, 203? Is that right? Add it in my head. Don't ever trust me to add in my head. Questions? How do I know when to stop?
When you start to go over the.
234. Say that again?
The highest limit.
Yeah, look at my highest limit. My highest class limit is 265.9. So as soon as I get past that one, then I'll be in my last boundary. So am I there yet? I don't know. I'm almost there. If I add 31 to this one, that's 265.95. So I just went past this guy, so that's how I know where to stop. Guess what though, I missed one. There's one that I missed. So we found all the numbers that come at the ends of all these. 110.95, 141.95. So if I was checking off, I found the numbers that came in all these places. We agree that all of those numbers come after those? Did I find the one that starts before this?
Yes.
Yeah, the 234.95 is before this one. I have all these even. Guess which one I don't have? Ah, the very first one, the one that comes right before the first class. The boundaries are before and after.
So would you just subtract 31?
Yeah, subtract 31 to get back over here. Because you don't really have another number over here to average. So the best thing to do is either follow your pattern or just subtract 31, and you would be at 31, 79.95? Is that right? How many class boundaries do I have? There's 7. How many classes do I have? Why is there an extra one?
Because we found the value before the.
Because you have the before and the after. So there's always one more boundary than you have classes. I had 6 midpoints, 1 for each class. But my boundaries, there are 7 of them. And again, on my stat lab, they want you to enter these separated by commas. Questions? Okay, let's take a 10-minute break. Come back in 10 minutes. If you go outside to look at the big list, do not get blinded. I'm going to go to see. Quizzes are always out of 10 points. So if you got a 10, it was perfect. Can I have your attention, please? Thank you. If you got a 10, it was perfect. If you got something less than a 10, maybe you were on the right track, but you got some of the points. I will always make comments about what you should have done, what we were looking for, and so forth. If you got a 3, that means it was not anywhere near perfect. 3 is how many points you get for showing up and putting your name on it. Because my quizzes are designed to have you here on time and ready for the class. If you're here on time, you get 3 points for that. But the other 7 points are for knowing what you're doing on the quiz. The only people who get 0 on my quizzes are the ones who weren't here on time to take it. Either not here at all or got here late. That's how I can tell who was here and who wasn't here and so forth. So if you didn't get a 10 and you don't understand why, please talk to me after class and we'll discuss it. But most of you did pretty well on it. But every quiz will be out of 10 points. Okay with that? Okay, so I need to collect some data from you so we can do another frequency distribution. And we're going to create it from scratch. Oh, so before we do that, top of page 15. Top of page 15 says normal distribution. The normal distribution is going to come up over and over and over and over and over and over again this semester. This is the first time we're going to see it. A normal distribution is a distribution that's kind of a bell-shaped curve. You know, everyone wants an instructor to curve their grades. What you mean by curve their grades is not actually what we mean by curving your grades, though. Usually curve means put it up higher, for students at least. But a curve is where the numbers start low, they get higher, and they get low again. If you made, say, a picture, how many people were in this category, that category, if it looked something like this, where I have 5 classes, and this is the frequency. So I had a few people, more people, the most in the middle, and then it goes back down again. That would be a normal distribution. This one right here. Now think of it as sideways. Is it normal? Does it start small, get bigger in the middle, and then get small again? Yeah, I mean, it's not totally balanced, but roughly normal, I would say. It starts small, gets bigger up to the middle, and then starts getting small again. So we'd say that's roughly normal. It's not really extremely not normal, right? Not perfectly normal. We call it roughly normal. So a lot of times you'll be asked to find a frequency distribution and asked if it's a normal distribution. And they're saying, does it follow a bell shape in terms of it starts low, gets high, gets low again? Or if you're looking sideways. Okay, on our first definition of normal, we'll get it a lot more times throughout the semester. Okay, now, example B. I asked you all about your favorite candy, or your choices of candies earlier. Now I want you to think about, in 1 week, how many hours on average do you spend studying? It's going to be different for different people. Some people have lots of classes, some people work, some people study more than others in general. We're not going to judge anyone, but I'm going to ask each of you to give me your number. Okay? Think about it. How many total hours per week do you spend studying? Your definition of studying, you know, some of us are sitting in front of a TV with a book open, call that studying. Other people wouldn't count that studying. I don't know. It's up to you. Everybody have their number? Okay, we're going to just go through the whole list. I'm going to list every single number up here. This is what I have here, where it says, here are the estimates. I'm going to list all these estimates. Let's start with you, Anna. 2 hours per week, she says. 5. Let's go ahead. 2. I'm talking about all your classes, by the way, not just ours. Yes. 0. We're not judging. Yes. 4. I'm giving points for honesty. 5. It's your turn. 8. You don't have any friends? It's okay. We're not judging you on that either. Some people study more than others. Yes. 3. 3.
7.
And 7. Yes. 3. 2. 2.
5.
And 5. Okay, well, where am I? Over here. 2. 3.
Yeah.
2.
2 and 2 or 3? Okay, now we're over here. 4. 1. 2. 4, 1, 2, 2. Okay, 3,
2.
2,
2.
and 2. I have a comment to make, but I'm waiting until we're done. Yes, 3, 2,
6.
and 6. I'm over here now. 2, 10, 5, 4.
Oh, me?
Uh-huh. 2, 10, 5, 4, 6. And 4, 4, 3. Okay, Alex. 2. 4, 4, 3, 2. And last round. 4, 2, and 4. Okay, so here's my first comment. You guys know this is college, right? What? That's my first comment. I almost always have somebody that's at least in the teens or the 20s. But have you heard?
Yeah, we just started.
You're just what?
We're just starting.
You're just starting, that's true. Maybe you haven't figured it out yet. You're estimating now. I like that answer. They haven't figured out yet how much you should study. The standard rule for college is that for every hour you spend in class, to be successful, you should spend 2 hours outside of class.
You said there's 3 hours.
It depends on the class. I'm estimating. We're estimating. So you guys got that? For every hour in class, 2 hours outside of class. So for just my class, we spend 4 hours a week in the classroom. So the minimum should have been 8.
2 hours of lab, right?
Right, the lab was part of studying. I would count that, right? Yeah, if you count the lab, then the number should go even more. And then if you have any other classes, it should go up even higher. So some of you will learn this lesson the hard way. I actually did my first semester at college as well. I was ready to take a bite on it. Wait, I'm not doing very well. I should have studied. Never studied so much in my life at the last minute. But anyhow, these are the numbers that we have. So we're going to make our own frequency distribution. A frequency distribution is we're going to make a table like this one. It may or may not be huge, depending on the directions. So we're going to fill in the directions right above that table there. We're going to fill in the directions. The reason there's blanks there is it all depends on the numbers you guys give me that I want to use. So it says construct a frequency distribution for the above data, beginning with a lower class limit of 0. Lower class limit of 0. And I want to use a class width of 2. So these are the two numbers that you need to fill in there, 0 and 2.
Did you just make up 2?
I did. I make up the numbers based on the data I have here, so our table will be reasonable. If somebody had told me they spent 100 hours a week studying, awesome, is there 100 hours a week? There are, I didn't think about that. You could spend 100 hours a week studying. Then I wouldn't want to count by 2s because it would take me forever to get to 100, right? So based on the data, I changed those numbers because every class gives me different numbers. And peer pressure makes people start answering similar to other ones. So there's probably someone here who wanted to say 20, but they didn't want to look so different from everybody else. I'm guessing. So anyhow, I make up those numbers. So doing that, and then we also want to include the relative and the cumulative for this distribution. So where should I start? I mean, it says make one of those, make a frequency distribution. Should probably start with 0. So for the first class, I'm going to start with 0. And then what? 0 to 2?
Yeah.
I'm hesitating. I'm writing it because you told me to.
All right, raise it.
Aha, that's not the width. Why am I hesitating? Why is it making me uncomfortable? Why does she want me to erase it? Where does the class width go from?
In the middle.
Could be from the middle, but it goes between
It's the midpoint.
two classes, two lower classes. So if this one is 0, the next class should start at 2. Well, I can't have 2 here and 2 here.
So 1.5.
Oh, hang on. Good question. Let's not even put anything there yet. We agree the next one has to start at 2?
Yep.
We'll worry about the upper class limits in a minute. The next one will be a 4, 6. How do I know when to stop?
Because the highest answer is
I need to look at my highest number, which is 10.
Yep.
So I have to at least go to that one. To make sure that every number in my list is in some class up here. I don't know where they end yet, but they're all in there somewhere. So now the question is, what comes at the end right here? Some of you are saying 1.9, which wouldn't technically be wrong, but do we have any decimals up here?
No.
Everything is whole numbers. If we had decimals, I would have to include decimals in my classes, but I don't have any decimals.
So to 1.
Just 1,
Just 0 to 1.
2 to 3,
That's,
4 to
you
5.
always want to ask yourself, what's the number that comes right before this one? And because they're all whole numbers, it's the whole number that comes right before it. If there had been decimals, I would have gone to 1.9 like you guys said. But there weren't any. Nobody said I'd study 3.8 hours a week, but you could have. You could have, that would have made sense. It's a continuous variable. So what's gonna go here? 3. And then we could keep just adding 2, right? All the way down here.
To 10.
11, right? We're adding 2 each time? Does everyone understand what I mean about if we needed the decimals or if we don't need the decimals? Because when you do these for your homework, sometimes you need them depending on your data. Always look at your actual data. Are there decimals? Then we're counting with the decimals. If there's not, then we won't. It has to match. So those are my classes. Excuse me. We've created the classes. All we did to create those classes is to make sure we knew the starting point and the ending point so we knew when to stop. Other than that, we didn't really look at the numbers. We just had to find that biggest one to tell me when to stop. Now, I need frequencies. How am I going to get the frequency? I'm going to count how many are in each class. So I'm going to go through right now and count everything that's between 0 and 1.
2.
I'm going to cross them off as I go so I don't lose track.
And there's a 1.
There's a 1 somewhere. There it is. There's 2 numbers that are between 0 and 1. So there's 2 here. And then we want all of the ones between 2 and 3. I think there's a whole bunch of them. Let's see if we can count the same number. 1, 2. What did you guys get? I got 22. You got 23? 22? I think most of us got 22. Raise your hand if you got 22 if you were actually counting. Okay, I think we outnumbered and we got something different. Everyone all right where the 22 came from? Now we want all the 4s and 5s. This is 11, let's double check.
11, yeah.
4, 9, 10, I got 11 too, that's good. We're just counting 6 and 7s, even less of those, I know that. Here's 1, 2, 3 of those. 8 and 9s,
1 8.
there's just 1 8.
And
The
1.
reason I'm crossing them off, by the way, is to make sure I didn't skip anything. And then we have 110. Is everything crossed off now? That's exactly what I was thinking. Someone over here said, someone didn't vote for the candy. Because you add those all up, there's 40. Maybe somebody came in there. There's 4. Remember we had 39 numbers earlier? Now there's 40. It's okay. It was a hard choice, I agree. So we have created the frequency distribution. So when the directions say construct a frequency distribution, That's what it's asking for. You have to first create the classes and then just count and see how many are in each one. We're right there? Okay, so next would be the relative frequency. What am I going to do?
Add up all the groups
Add them all up, because I need to know the total.
and divide by 6.
Ooh, not divided by 6. Add up all the frequencies, which I think now adds up to 40, correct?
Yeah.
I do 2 divided by 40, 22 divided by 40, 11 divided by 40. Each one of those gets divided by 40. I'll let you do that for me. Everyone okay on how to find the relatives? Divide each one and then turn it into a decimal for me. Let's round to the nearest whole number this time. Nearest whole percent. I like the sound of the calculators going. That's what it sounds like on a test day. You hear all these click, 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 click. Turning to a decimal, then rounding to the nearest whole percent. Some of us are calculating faster than others. If you haven't quite finished, you can copy these down and check your work later. What do we get for the first one? 5%? And the next one?
55.
55?
28.
28? Had to round that right, it was 27.5.
8. And then 3 and 3.
3 and 3?
Yep.
Anybody have a question on how we got those numbers? I just quietly let you guys all work on them. If you're shy and confused, we need to get over one of those two things. Yes?
Are we rounding the percents because it's whole numbers, or?
We're just rounding to the whole percent because I said round to the whole percent. We could have said round to the nearest tenth like I did last time. I could have said round to 2 decimal places. So where you round just depends on the directions and it changes all the time. I just chose the whole percent this time, yes.
Are we running just the whole meter?
Well, we talk about percents with decimals, so it doesn't, it's okay. I mean, to say 7.9% is accurate as well as 8%. It depends on where you're choosing to round. And so it's not because it's out of people, because it's out of 100, if you had exactly 100, which we don't, so it doesn't really matter. What do these add up to?
1 and 2.
102.
Because
Uh-oh.
you round up.
What'd you say?
Because you're the round.
Yeah, because we had to round a couple times and we rounded pretty drastically.
Yeah.
Where like, I think 3 places you had to round from 0.5 up, so we actually went up to 102. That's okay, it's because we rounded to the nearest whole number, we're less likely to get exactly 100. Remember last time we were at 99.9, we were pretty close because we were keeping more decimals. The more decimals that you keep, the more accurate you're gonna be closer to 100 when you go to check it. Okay, I'm not too worried about it. Questions there? Now let's do the cumulative. Cumulative. See if we remember how to do that one.
Would you just add?
Add what? I didn't hear what you said.
The frequencies.
The
top
frequencies.
To the bottom, or the 22 to the 2 to get the first one.
The first one actually is just
Oh,
the
just
first
two.
number. So there's 2 people that study between 0 and 1, that basically study 1 hour or less per week. And then I'm gonna add those 2 and get 24. Tell me about those 24 people.
The study is between 0 and 3 hours.
Between 0 and 3 hours, or you can just say 3 hours or less, same thing, right? 3 hours or less per week. So that's what the cumulative kind of puts all the people together. You can quickly say how many study 3 hours or less. The next one, we add the 11 to get the next one. So we have 35 who study 5 hours or less, because it counts all these. And you just keep adding your next number. Then you have 38, 39, and then 40. Remember that this total better match this total. Those are doable. It's a little bit harder to create them from scratch. There'll be problems like this where I give you a distribution and ask you questions like we started. Sometimes it's harder to start because you have to first come up with your classes. If you don't start with the classes, you have no idea what to put over here for your frequencies. Once you have the classes, then you can just count. Questions? I have 2 more questions about that. What are the class boundaries for this particular example right here? Class boundaries. Say that again? Let me list these and then we'll talk about where she's getting those. She's right. The class boundaries, the first one was 0.5. I'm not so sure about that one. But we'll go with the ones after that. Her next one was 1.5, 2.5. I'm underlining this one for the moment. I'm coming back to it. Sorry, I'm going too far. 1.5. She just figured out her mistake too. 1.5, 3.5, 5.5. So she's right except for this one, but she already figured out her mistake. You guys just couldn't hear her. We'll fix it in a minute. In words, what are the boundaries?
Don't you add
Just give me a hand to it. Between
What is separating
the
classes?
between the things, between the classes. The numbers between the classes. So this class ends at 1, and then the next one starts at 2. So halfway between 1 and 2 is 1.5. And then this class ends at 3, and the next one starts at 4. So halfway between there is 3.5. You okay with those? What's the difference from one boundary to the next? Has to be 2. It's that class width again. So we keep adding 2, adding 2, adding 2. How do we know when to stop? After we pass the last class, right? What's wrong with this one?
It's between 0 and 1.
Yeah, you can't be between 0 and 1. That's inside the class. So there's a problem right there. See the problem? It can't be that because 0.5 is in the class. It's supposed to be what comes before the class. It's okay. It's going to feel a little weird, but you'll be right. It's going to have to be negative because it comes before 0. Negative 0.5.
Oh, because it's before the 0.
It's before the 0, and it has to be 2 before this one. Remember, we're always adding 2. If you take 1.5 and you subtract 2, you get negative 0.5. Now 0, the 0 and the 1 are definitely in between those 2 boundaries. Right? And the 2 and the 3 are between those 2 boundaries. So these are all of my class boundaries here. What about the midpoints?
0.5, 2.5, 4.5, 6.5, 8.5, 2.5.
0.5, 2.5, 4.5.
Oh, because you're just adding 2 to them, to the boundaries?
The width.
Not adding to the boundaries.
Yeah.
You're adding it to the midpoints.
How'd you get the first one though?
Add the 2 together.
So halfway between 0 and 1 is
Uh-huh.
0.5.
Halfway between 0 and 1
Yes.
is 0.5. That's where he got the first one. And then what do we do from there?
Same thing.
Keep adding the class width, add 2, add 2, add 2.
Until you hit the limit.
Right, until you hit the end. Or you could find halfway between each of these if you wanted to look at them that way. Right in the middle here is 0.5, right in the middle here is 2.5, right in the middle here is 4.5. Whichever way you want to look at it will work. How many midpoints do I have? 6. Because I have 6 classes. How many boundaries do I have? 7. There's always one more for those boundaries. So we okay on class limits, class width, class boundaries, class midpoints, creating the distribution? Yes.
I just have one question. So just for when you go to class, I get like how you started off at 0, but how did you know it was 1 instead of 2?
Okay, so it told us to start at 0. Did you filled in this part at the top that said
Yes.
start at 0 and have a class width of 2? So I started by writing the 0 here, and then knowing that the next class I had to add the 2 to start the next class, and add the 2. So that, I like to do all these numbers first, all the lower class limits first. And then I look at my data and say, oh, what comes right before this number? That's where the 1 came from, because 1 sort of comes right before the 2. All depends on what your data is, but it's what comes right before. Other questions? Yes.
Can you just explain how you got the negative 0.5?
Yes. So there's a couple ways I can explain. One of them is, you're okay with all those?
Yeah.
So I add 2, I add 2, I add 2, no problem. So if I'm going backwards, I would subtract 2 to get this one, subtract 2, subtract 2. If you take 1.5 and you subtract 2, you get negative 0.5. So that's one way to look at it. The other way is 1.5 is at the end, it comes right after this. On a number line, what comes before 0 would be something that was negative, right? So that's where the negative 0.5 comes from. It starts this and then ends over here.
Oh,
And then this one, the 1.5 comes right before it, and then you end up at 3.5.
okay.
So these numbers here, this one I wrote twice, the 1.5. But then the numbers that come before and after each of the boundaries,
Okay.
excuse me, each of the limits.
Uh-huh.
And that first one is tricky because sometimes it comes out negative. I can't have a negative amount of studying, but you need to have some number that comes before 0. It's gonna have to be negative.
Okay.
I saw another hand. Was it the same question?
Yeah.
Okay. Other questions? These are good questions. Okay, so now we're gonna draw pretty pictures. So section 2.1 was all about these frequency distributions. 2.2 is about drawing what's called a histogram. It's basically a picture of your distribution. So we're going to draw a histogram for each of the examples we just did today. The description there says, it's a graph with bars of equal width drawn adjacent to each other. The horizontal scale represents the classes, and the heights of the bars represent the frequencies. Sounds all scary to me. So I'm going to do the one for example B first. Example B is the one we just finished. There's 2 of them down here, A and B. I'm going to do the one for this, but we just finished talking about this one. Then I'll go back to the one we did earlier before the break. So I want to make a histogram. I have a horizontal axis and a vertical axis, like your X's and your Y's from algebra. On the horizontal, it's going to represent my classes. The most common numbers to put on there are the boundaries. So I'm going to list, I'm going to maybe make this a little bit longer so I can squeeze them all in here. I'm going to list all of my boundaries on that axis, starting with negative 0.5. So I'm going to put negative 0.5 here. The next one is 1.5. I forgot which one of my boundaries now. Listing all my boundaries, 3.5, 5.5. How far do I have to go? 11.5?
Yes.
Notice that these should be roughly, my graph is not, they should be all about the same distance. This one's a little bit fatter, but they should be the same width. Use the power of my eraser to make it a little bit more accurate here. So each of these classes that are separated by these boundaries should all be the same width. What is that width? 2. That's the class width. From here to here is 2. From here to here is 2, right? However wide you make them when you draw them is up to you, but they should all be evenly spaced or close enough if you're freehanding it like me. So then I want to just mark the frequencies. My frequencies go from 1 up to 22. So I am going to mark this scale so it at least goes up to 22 because I have to fit that on my y-axis. So maybe I'll count by 5s and go up to 20, go up to 20 maybe. Like here's 5. Again, evenly spaced, 10. My spaces keep getting smaller as I go. 15, 20, something like that. Those should be evenly spaced. And I just want to make a bar that goes up to the height for each class. So this first class goes up to 2. 2 is roughly right here. So I'm going to go up to 2, over, and down. Where this number right here is 2. It matches up with this 2 right here if they were marked. You can count by 1s if you want. It just gets really smushed together if I try to mark them all for you. It's hard to read. Everyone okay? I just went, for this class, if you're between these 2 numbers, there's 2 in that category. Between those 2 numbers, there's 2 in that category, in that class. The next one, though, had a 22. So it's going to have a much taller bar here. 22 is way up there, past my 20, about there. I'm eyeballing it. Sorry if you can't read this exactly. You don't have to put the numbers on top. A lot of times you'll see them written on top if it's hard to read over to your scale. Other times there'll be a nice perfect number line and you can just look over and see that it's a 22 by looking at the graph. 22 in the next class? We'll put 11 in the next one. 11 roughly here. Everyone see what I'm doing there? Then I have 3. And then I have 2 1s. So my graph, I'm going to color those in so you can see them. This is called a histogram. Questions on how I just created that? Mark your boundaries, find the heights based on your frequencies, draw some little straight lines. Important, equal width, so you have to count evenly spaced. What if I had a class that was like a 0? What if nobody said anything between 6 and 7 and it was a 0? What would I have done?
Skip the bar.
Yeah, just skip that one. If there was nothing in here between 6 and 7, I just would have had no bar right there. It just would have been like a flat line, you just wouldn't see it. The bar would just be empty. It's okay, skip that one. But you have to at least keep a space for every possibility in between there. So it has to have everything with equal width. And the other thing is that they are drawn adjacent to each other. They have to touch. It makes it a histogram because they're touching. If I had tried to draw it with my class limits, 0 to 1, 2 to 3, they wouldn't have touched. Let me do a little rough, quick sketch of what I mean. If I had marked my number line, 0, 1, 2, 3, 4, so forth, 0 to 1 would have gone, up here. And 2 to 3 would have been up here. There's this weird space between there. See what happens? That's why we have to mark it with the boundaries. It's like, what happens? Why is there a weird space? It has to be touching. This would not be okay. If you mark with your boundaries, that's the easiest way to do it. We don't like to mark with class limits because you can't tell if the 1 is on this bar or that bar. If you mark the brand at 1, which side are you on? Your problem. Okay? The horizontal scale can be marked using boundaries or midpoints. Sometimes, instead of listing the boundaries like I did there, they will label just the midpoints. They'll label these numbers. Everything would look the same, But instead of listing the edges, they would just put what's in the middle here. They'd put 0.5, 2.5, 4.5, so forth, and label those. You'd still be able to tell the width and figure out everything else. More common is to use the boundaries. So that's my histogram that goes with the data we just came up with. Is it normal? Is it normal?
Yeah.
Starts low, gets high in the middle, and goes back down?
Yeah.
I heard yes, I heard no. Is the middle the highest, guys?
No.
Definitely not, right? It's much higher over here. We call this skewed. It's skewed because we got all this higher part over here and then it kind of gets stretched out over there. It's not very normal, it's skewed.
What's the definition of skewed?
Skewed kind of like it leans. It leans one way, or it's not really leaning, but
Okay.
it leans one way or the other.
Okay.
If you were to draw a bell shape over it in this example, it would look something like this. Rough sketch. So it's not highest in the middle, it's skewed, it has this little part that stretches over here to the side. You have skewed left and skewed right, where maybe you have something that does this, right? Skewed, yeah. The book will explain it in more detail, it's mine where it's leaning over. It's not very normal though. Okay, and how to make a histogram. Okay, so let's make a histogram for that example A that we started with today. The one with the classes, or excuse me, the houses, the housing prices. The housing prices, I'll make that one over here. What should I do first?
Find your boundaries.
Find my boundaries, which we already did. Oh, throw some papers on the floor. That works well too. Now that we found the boundaries, what do we do with them? We found the boundaries earlier.
You'll use them on the bottom.
Use them on the bottom. Mark the bottom with your boundaries. Someone remind me what they were, please. What was the lowest one? The smallest boundary. This is the example A from earlier today. 79.95. And then, someone read them to me, please.
110.95,
Thank you. Keep going.
141.95, 172.95,
Okay.
and 203.95, 234.95.
Got it? Go one more. Is that all of them? Yeah? I only see 6 here. Weren't there 7?
No, isn't there one more?
There should have been one more.
265.
Okay, good. Wait a minute. There's not enough. 265.95? And it's not here. So I'm marking my x-axis, my horizontal axis with the boundaries. Those are the boundaries we found for that example earlier today. Just writing each of my boundaries there. Now what do I want to do?
Now you wanna count how many homes were sold in those frequencies.
Okay, so I want to count how many were sold in each class, which I have that in front of me. Something else I want to do before I look at those. Well, I need to look at those and make a decision here. What am I going to do next?
Label your y-axis.
Yeah, I need to label my y-axis. How do I decide how to label this?
1 through 10, by looking at your data.
Looking at my data, look to see what the highest number is here to make sure it will fit. In that problem, I counted by 5 because I had to go all the way up to 20. In this problem, though, example A, I only have to go up to 10. I think I'll just count by ones up to 10.
Yep.
Evenly spaced, right? You have to decide how to label it before you can start drawing, because otherwise, where's 10? I don't know where 10 is. Yes, ma'am.
To label the y-axis, you just put boundaries and frequencies, it should be like boundaries of,
Usually what we write here is we write classes, and then we write frequencies. I'm glad you asked that, though. more importantly, is that the title of the whole thing should be labeled correctly, and it would be sale prices of homes in thousands, and then this would be very clear what it would be, because then you would know that between here and here. So the title of what the class is actually described would be the title of your histogram. Good question. Everyone understand her question? So then I'm just gonna go up to the correct heights. So if the first class goes up to 2, by the way, these are all straight lines. Use your imagination. The second class goes up to 5. The next one goes up to 7. They're wiggling. All the way up to 10. Then 3. And then 1. A little rough picture. Pretend those are straight lines. Those things are slippery. Questions on how I got there? Copying mine is one thing, but being able to draw your own is what you need to be able to do. Remember we talked before, this one looked like it was roughly normal? It's not perfectly normal, it's not really high right in the middle, but it's pretty close. It's a little bit skewed, but not by much. That's why we said it was roughly normal. It's pretty close. It's much closer than that one, where you have the little pieces off to the side and the big chunks on the left. Questions? So on your online homework and in your lab assignment for next time, you're going to be asked to find class limits, find class width, find boundaries, find midpoints, make histograms, create your own distribution. You can handle that. Questions? Okay, I will see you guys on Wednesday if I don't see you in the lab beforehand. I'll be in the lab in a few minutes.